we are going to be looking at direct variation. To do this, we're going to explain what direct variation is. We're going to also examine the steps that we use to solve direct variation problems. And then we're going to also solve direct variation problems, including word problems. So direct variation is just a way to express a relationship between two quantities. We represent it as x varies directly as y, or you can also say y varies directly as x. And we represent it with y equal to kx, where k is the constant of variation. And the important part about direct variation here is that as one quantity increases, the other quantity also increases. Now you may ask, how do I go about solving direct variation problems? The first thing you want to always do is write it as an equation. Here it shows that y varies directly as x, with k being a constant of variation. The next thing we're going to do after that is to find the value of the constant of variation or the constant of proportionality. And then when you find that value, you can rewrite the equation with the value of k, which is our constant that we found in the previous step. And then we will use the equation to find any missing information. Let's go look at some examples and then you can see how to apply this. So we're given here that y varies directly as x. So y varies directly as x. We want to find the constant of variation if y is 24 and x is 3. So y is 24 and then x is 3, so we have k multiplied by 3. So we want to find the value of k, which is our constant of variation. Some call it the constant of proportionality. That also works. So we can divide both sides by 3. And then we can see that 8 is equal to k. So our equation now becomes y is equal to 8x. And this is what you want to aim for when you're trying to deal with direct variation. Suppose y varies directly as x and y is equal to 30 when x equal to 6. What is the value of y when x equal to 100? So our first step is going to be y equal to kx, and then y is 30, and then we have k multiplied x is 6. So we're going to divide both sides by 6. And then we have k equal to 5. So now our equation is going to be y equal to 5k. So now it's asking what is the value of y when x equal to 100. Sorry, this is not 5k, it should be 5x because k is 5. Y is equal to 5x. Now we want to find the value of y when x is 100. Y is equal to 5 multiplied by 100. So y is equal to 500. So that is the value of y when x is 100. Next equation. If c varies directly as the square root of d and c equal to 6 when d is equal to 256, find c when d is 625. Okay, so let's go ahead and write the equation. So c varies directly as the square root of d, so it's going to be k multiplied by the square root of d. Now c is equal to 6. We need to find the value of k when d is equal to 256. So c is equal to k multiplied by 16, and then we divide both sides by 16. So k is equal to 6 over 16. We can simplify this by dividing both sides by both numerator and denominator by 2. So we have 3. Okay, so k is now equal to 3 over 8. So now our equation is going to be c is equal to 3 over 8 multiplied by the square root of d. Now we want to find the value of c when d is 625. So we have c is equal to 3 over 8 square root of 625, which is going to give us 3 over 8 multiplied by 25, and then we have 75 over 8. C is equal to 75 over 8. If you want, you can simplify this to mixed fraction, mixed number if you prefer. Doesn't make a difference. You can change it to decimals if you like. Doesn't really make a difference. Now, the distance a body falls from rest varies directly as the square of the time it falls. So the distance varies directly as the square of the time it falls. So I'm using d for distance and t for time. So if a ball falls 144 feet in 3 seconds, okay, so our distance is 144 feet. We need to find k, and our time is 3. So we have 144 is equal to 9k. We divide both sides by 9, and we have k is equal to 16. So now our equation actually is d is equal to 16t squared. Okay, how far will the ball fall in 7 seconds? So d is equal to 16 multiplied by 7 squared, which is going to give us 16 multiplied by 49. Let's go ahead and do that right here. 49, 16. We have 4 here, 294, because we bring 5 up here, and then we put a 0 here. This is 9, this is 4. We add this up, we have 4, 8, 7. So d is equal to 784 feet. Final example here. The distance required to stop a car varies directly as the square of its speed. The distance required to stop a car varies directly as the square of its speed. I'm going to use s for speed. If 250 feet are required to stop a car traveling at a speed of 60 miles per hour, okay, so we have k, and then we have 60 squared. Now we want to find the value of k, so we have 250 is equal to k multiplied by 60 times 60. So we divide both sides by 60 times 60. 60 times 60. So we have, this is going to cross out perfectly, and then we're going to cross this out right here. We can also divide this by 5, divide this by 5, we get 12. So now we can say confidently that 5 over 6 times 12 is equal to k. So therefore, k is equal to 5 over 72. So now our equation is d is equal to 5 over 72 s squared. So now how many feet are required to stop a car traveling at 96 miles per hour? So d will now be equal to 5 over 72 multiplied by 96 squared. which is equal to 5 over 72 multiplied by 96 multiplied by 96. So here we can go ahead and divide this by 6. We can divide by 12. This is going to give us 6. Divide by 12 here. This is going to give us 8. We can divide this by 6, and then we divide this by 6. It's going to give us 16. So 5 times 8 times 16. So D is equal to 5 times 8 times 16. When you multiply this out, you should get 40 times 16, which is, let's do it right here, 40 times 16. 16 multiplied by 4 is 64. We'll put a 0 at the end. So therefore, D is equal to 640 feet. So if you're driving at the speed of 96 miles per hour, you're going to need a stopping distance of 640 feet.